In this section, we're talking about density and displacement. These are probably topics that you've already discussed in your physical science classes. Here we're working with volume, so these come up as applications of that. And so displacement, let's first talk about that. So I have this prism, and let's say that we've got it's got some water in it already, and I drop a clump of metal down into the bottom of this. All right, so when I drop that clump of metal into the prism, our water level is going to go up. All right, and so when we're talking about displacement, what we're really talking about is the amount of water that has been displaced by that clump of metal. So imagine this slice of water across here. That's what we're really going to focus on, is that slice of water. Not the entire prism full of water, just this slice of water that has been displaced by that clump of metal. All right, so when we focus on that, whatever the amount of change in our water level, let's say this case it rose 2 centimeters, that would be like the height of this slice of water. And whatever our base was to begin with, that would give us our dimensions for the base of that slice of water. So as a result, when we're talking about the volume of this object, whatever the object is, in this case we're talking about the volume of this chunk of metal, that volume is going to be equal to the volume of this slice of water. Now, we've already been working with prisms and cylinders, and we know that for the volume of prisms and cylinders, and for the sake of density and displacement, we are only going to be working with either a prism or a cylinder when we're talking about the displacement of an object. But when we're talking about the volume of prisms and cylinders, we've been taking the area of the base times the height. Now, the area of the base, well, if we're talking about a cylinder, that base would be a circle. If we're talking about a prism, then that base would be a rectangle. And the height, well, that's going to be, come back to our slice of water, that's going to be the change in the water level when we're talking about displacement. So, to our example, our base in a rectangular prism, well, the 6 here, that's our 6 right here, and the 8 right here, that's our 8 right here. So the area of the base we would find by taking 6 times 8. And as far as the height, well, that was the change in our water level of 2 centimeters. So when we're talking about the volume of that object, or the volume of that slice of water, this would be how we'd find it. We'd take the area of the base times the height. So we would get a grand total of 96 centimeters cubed. Okay, so now that we know the volume of this object, 96 centimeters cubed, let's now talk about the density. So density, we will find density by taking mass divided by volume. So things have different density. We're talking about if you have 100 pounds of feathers and 100 pounds of gold, they're going to take up a different amount of space. That's based on their density. For the sake of our examples, when we're talking about the mass of something, we are going to measure that in grams. And when we're talking about volume, that's going to be measured in cubic centimeters. On page 551 in your book, or for this assignment, I did put a PDF available on your Google Doc that has all the assignments. But on page 551, there is a chart that lists the different density of different objects. All right, so that chart looks like this, and we've got 5 different metals on this side, their density, 5 different metals here and their density. So we have that chart available to us in our book. Now, for the sake of this example, let's say that we have that particular object that we were just working with that we dropped into the water. Let's say that we measured its weight, and so we were given that it has a mass of 1,084.8 grams. So that's given information, all right? And then we're asked, well, if we know this mass, what is the density? All right, well, we know density is equal to mass divided by volume. So for this problem, 1,084.8 grams divided by volume, we had already found was 96 cubic centimeters. So when we divide that out, get our handy dandy calculator. So I have 1,084.8 divided by 96. And we get a value of 11.3. And then our label, well, let's see, up here we were dividing grams by cubic centimeters. So our density label would be grams per cubic centimeter. Then if we go back to our chart, we can determine 11.3 grams per cubic centimeter. That's showing up right here. That metal would be lead.